All right, let's check this dude out. Consider this differential equation. Okay, here he is. Look how pretty he is. All right. On the axis provided, sketch a slope field for the given differential equation. Now, I'm so lazy, I'm not going to redraw this. I'm going to do it right on here. Now, because there's an x and a y, you got to plug in the x number and the y number. So let's do this one right here. What's the x number and the y number for that? -2 and +2. That's right. Good job, guys. So what would -2, +2? So -2 times +2 divided by 2. What would that equal? -2. Okay, so this is a -2 slope right here. So my baby tangent line is going to be like that. All right. So I'm going to continue this pattern to finish this. Just plugging in the x and the y for every single point. Oh, let's do another one. Let's go -2, and then it'll be +1. So what would that be? If I divide that by 2, that would be -1, right? So -1. So it's steep, but not as steep, or negative slope. And then if I plug in this one right here, that's going to be a 0y, which means the top would be 0. 0 divided by 2 would just be 0. So we have a horizontal line right there. And then things changed right here because now we have a -2 and a -1. That's going to make a positive on the top. I divide that by 2, it's going to be a +1. Okay, so you guys kind of see a little pattern right there. Let me finish this. So there is your slope field. That's what it should look like. But now let's read the complicated things. This says, let f be a function that satisfies the given differential equation. You know what that means? The only thing that means is this is the derivative of f. That's all you need to care about. Okay, this is the derivative of f. Okay, write an equation for the tangent line. Okay, you guys know how to write an equation for a tangent line? Let's pause for a sec. I just saw a calculus word. I saw tangent line, and you guys thought this. I know you did. Right away, you guys thought y minus f of a equals f prime of a x minus a. You guys thought that, didn't you? Yeah, because that's the slope, that's the y value, and that right there is the x value where you're finding the tangent line. Okay, so then we continue reading because you guys already know this in your head. You're like, oh, I know that, to this curve, okay, through this point. Hey, look, there's a point. Okay, so what do you suppose the 1 represents for our tangent line? Hey, that's right, man. You guys are on fire. And then the other one is the y value for the a. Okay, man, you guys are crazy. Then use your tangent line equation, there he is, to estimate f of 1.2. So we first have to find the tangent line. Then we're going to plug in 1.2 into it. Okay, so let's plug our stuff in. We have y. What was f of a? Oh, yeah, it was 1. And then what is f prime of a? Ooh, 1, 1. So 1, 1's right there. What was the slope right there? What did I get? When I plug 1, 1 into there, what do I get for my slope? 1/2. Man, you guys are good. Okay, then we have x minus 1. And then I'm going to solve for y. I'm going to get y alone. So it says 1/2 x minus 1/2. And then I'm going to have to add 1 to that. So this is going to be my tangent line equation. You don't have to solve for it all the way, but I'm going to anyways. Because, what if you're doing multiple choice and it was solved for? Okay, so this is our tangent line. He's so pretty. Now I'm going to plug in 1.2. We're going to estimate the value of f. That's this guy, which we don't even know. We're going to estimate the value of f at 1.2. So how would we do that using the tangent line? You see, this has the idea of linear approximation. Have you guys ever heard that word? Maybe not. Maybe you did and you forgot. Approximation. What the heck is a linear approximation? That is, you estimate the y value using the tangent line. So like, let's say you had this curve like here, like, and like that, and you had this tangent line that went like this. This is a, and this right here is a plus a small number. If I plug this into my tangent line equation, I almost get the y value that's on the curve. That's called linear approximation. We are estimating the y value. So to find this, I'm going to go y equals 1/2 times, 1.12. I hate decimals. All right, what's half of 1.2? Do you guys know half of 1.2? I mean, is it 0.6? Yeah, 0.6 plus 0.5. Okay, so I changed the 1/2 to 0.5. I hate decimals. And this is 1.1. Okay, so that's your answer for B. All right, let's do the C. Let's see what C is. Okay, this one was B. We're gonna do C now. Okay, this says find that particular solution. Oh, there's another calculus word. Did you guys recognize that? Find the particular solution. Okay, so we're actually gonna find F now. Okay. To the differential equation with initial condition. Ooh, initial condition. That's a fancy word. Here's your initial condition. Use your solution to find. Oh, now we're gonna really find what 1.2 is. Oh. Okay, so we have dy over dx equals. Are you guys mocking me?
That's what you reminded me of.
You just compared me to something in the Wonderland?
Yeah,
Scooby-Doo? Oh, it's Rocky, you on your treat? Whatever. Okay, I'm going to multiply both sides by dx. Guys, your goal when you're solving for the general solution so that you can find the particular solution is to first separate the variables. So that's what I'm doing right now. Now that y has to go also. How do I get rid of that y? Let's see. If I write this a different way, does it make it easier? Does that make it easier? Okay, how do I get rid of that y? Multiply by 1 over y? Very good, Rebecca. Man, you are so intelligent. You're on fire right now. Sorry, I wrote 1/2 instead of 1 over y. Okay, next, what you need to do is you need to integrate both sides. Yeah. Okay, what is the integral of 1 over y? Natural log, absolute value of y. And what is the integral of 1/2 of x? That's going to be 1 over 4 x to the second power. Where did that 4 come from? Well, because it's a 2, I had to divide by 2. And when I divide 1/2 by 2, I get 1/4. And there's my plus c. Now, how would I find that c? Because if I want to find the particular solution, I must find c. In order to find the particular solution, you got to plug in the point that they give you. So my initial condition is 1, 1. We're going to plug that into the y and the x to find the c. And then when I plug the c in, we have found the particular solution. And then I could plug in 1.2 to see what the actual value is for this function. Now, to get the y alone, all you got to do is do base e to both sides. So I'm going to put, I'm not writing here for something. There we go. I'm going to put base e there and there. Okay. These are going to cancel out, and I'm left with the absolute value of y, which is going to translate to a plus or minus on the e. All right, but let me write this out first. Plus c. Okay, so this is plus or minus, and then we don't have to worry about the absolute value bars anymore. But we can also do a little bit more simplifying because of that plus e right there, or plus c. We can rewrite this as plus or minus e to the c power times e to the 1/4 x squared. Now, this is just going to be a constant. And we don't know what it is, but it's a constant. It's a number, so we could just say c times e to the 1/4 x squared. Now, we got to find out what that c is. To do that, we're going to plug in our initial condition or initial point, however the problem words it, is 1, 1. And it says it right here. It says f of 1 equals 1. So I'm going to plug in the 1 and the 1 into the x and the y. So I have 1 equals c e to the 1/4 1 squared, which doesn't have any real significance. And then I'm going to divide both sides by e to the 1/4 to get c equals e 1 over e to the 1/4, which can be written as e to the negative 1/4. But, well, it's calculus. You can have a negative exponent power, I believe. And now we can write the particular solution. Our particular solution, I'm going all the way back to this guy right here. Actually, no, I want to do this guy right here because he's already kind of simplified. We're going to have y equals e to the negative 1/4 times e raised to the 1/4 x squared. Now, so I don't have a negative exponent. I'm going to go ahead and simplify that just a little bit more. So we have y equals e to the 1/4 x squared minus 1/4. And then we can make this look different. We could say e to the, that would be x squared minus 1 over 4. So, and this actually looks nicest. So I'm going to use that as my particular solution. Actually, we'll leave a box around him. Now what we're supposed to do is say f of x equals this. All right, that's our particular solution. So let's plug in 1.2 to see what we get. Let's see, that would be e raised to the 1.2 squared minus 1 divided by 4. I'm going to throw this into my calculator, see what I get, and then write it down. And after I did that, I got 1.11627, so on and so forth. But that is a rounded answer, and this actually is pretty dang close to my estimated answer that I got earlier. All right, that means we must be on the right track. All right, so we just did letter D. It says compare your estimate of f of 1.2 that we found in the first one to the actual one that we found. We found that they're pretty close together. And the next question, E, says, what is your estimate from part B? Is your estimate from part B an underestimate or an overestimate? Use your slope field to explain why. Okay, it's clear when you guys look at this that this number right here, 1.1, is smaller than this number. Okay, because there's the 6, 2, 7, 8, whatever. So our estimate is smaller than the actual number. Why? Now this E is asking us to use a slope field to explain that. Now right here, right there is where 1, 1 is. Now if you look at that slope right there, that slope is a positive slope. Now what that means too, if we were to continue on drawing this line, we're curving up. In order to match this next baby tangent line, our curve is going upward. It is increasing. The curve is also increasing in its slope. And so we can say all those things. See, if we drew a tangent line, the tangent line would be below the curve. So we got to say all that stuff and articulate it for our answer in letter E. So I'm going to start off what I'm saying by just stating the obvious. Our estimate of f of 1.2 is an underestimate because, and I'm going to say, and I'm going to use this, our slope field, to explain it. And so I'm going to talk about the slopes, because the slope, or I should say, because f prime of 1 is greater than 0, that's just saying that the slope is positive. And you could just say the slope is positive at 1, 1. Because the slope is positive and the slopes, or just slope of f, is increasing. After x equals 1.2. or 1.1. We can also say the tangent line is below the curve. All right, there you have it. Now, whenever you guys do explanations, you got to make sure that you do what it says. It says use the slope field to to explain why we have an underestimate. So you have to reference the slope field or information that you get from the slope field.